Magnetic fields. Let's talk about magnetism and how it affects objects on Earth. We already know that magnets don't attract everything towards them. For example, if you place a magnet near a pencil, nothing happens. The same is true with a rubber eraser and a plastic ruler. However, put the same magnet near a paperclip or a screw and a nail, and they stick like glue. Why do some materials have strong magnetic fields and others don't? Well, it has to do with the atomic structure of the material. All matter is made of atoms. An atom is made up of a nucleus found at the center of the atom. Protons are nuclear particles that carry a positive charge. Orbiting the nucleus are electrons, which carry a negative charge. All of the electrons spin as they orbit the nucleus. The moving electron causes a magnetic field, making each atom a tiny magnet. In most materials, like wood or plastic, the magnetic fields of the atoms point in random directions, making the magnetic field weak, so it's barely detectable. Some materials, however, have clusters of billions of atoms all lined up in the same direction. This is known as a magnetic domain. In an object, such as a magnetized iron bar, all or most of the domains are arranged in the same direction. If a material can form a strong magnetic domain, it can make a very strong magnet. A material that shows strong magnetic effects is called a ferromagnetic material. Ferromagnetic comes from the Latin word ferrum, which means iron. Magnets can be made from any ferromagnetic material. One way to make a magnet is by placing the non-magnetized material in a strong magnetic field. This can be demonstrated by placing a ball bearing on a magnet and then adding additional bearings. They become magnetic while they are inside a magnetic field. When you remove the top bearing and move the magnet away, the other ball bearings fall one by one. Another way to make a magnet is to rub non-magnetized material, like this nail, with one pole of a strong magnet. This causes the domains in the nail to line up in the same direction, and the nail acts just like a magnet and can attract objects like a paperclip. We can use iron filings to demonstrate magnetic domains and how materials become magnetic. See how the filings are arranged randomly in the tube. When we rub one end of a magnet in the same direction several times, you see the filings are now arranged differently. They're all going in the same direction. The iron filings model magnetic domains. Some metals are easy to magnetize, like paperclips, but they lose their magnetism quickly. They're called temporary magnets. Other harder metals are more difficult to magnetize, but they tend to stay magnetized, like this bar magnet. They're called permanent magnets. Permanent magnets can become demagnetized too. By striking them hard or dropping them, domains can be knocked out of alignment. Heating a magnet can also destroy its magnetism. It's also interesting to note that if a magnet is cut in half, it creates two smaller magnets with both a north pole and a south pole.